I say a second, I mean right now. So the list of values that I'll give you, let's just say that they are 5, 3, 8, let's say 2 and 0, 1, 8, and 5. Cool. All right. So now, just like we were talking about earlier, in life, you get so much information that's unorganized. Boy, wouldn't it be nice if you just had a way of having things that were just a little less chaotic, a little less problematic? So one of the skills you do by parsing is just put things in order. Make it simple. So let's put these in order. So from least to greatest, 0, 1, 2, 3, 5. I have 2 5s and 2 8s. All right. You know what? This information's already starting to make a little bit more sense. It's ordered. I can see from least to greatest. All right. But these values are a data set. It's a set of numbers that are a collection of data. However, there are also some other values when we start to talk about central tendency, and those values are mean. No, not personality-wise. It's all mean. That was a joke. Okay. Mean, median, mode, and range. These are all values. You're saying these are words, man. No, they are words, but they represent a value. And I'll show you that in a second. What's up, dude? Fletcher, what's up? Sure. So we're dealing with mean, median, mode, range. Well, the way to find mean is, how do you find the mean, guys? Take the sum of all of these values right here in the data set and divide it by the total number within that set. Well, right here, I've got a total set of, looks like 8, 2, 4, 6, and 8. So this whole data set has 8 values. So what I'm going to do is add all of them up. Well, it looks like it might be 30 something. So 1 plus 2, 3, 6, 11, 16 plus 16 is 32. So this is 32 over, and the total set of values is 8. So the mean is, you're going to take the sum and divide it by the total set, which is 32 over 8 is what, Dean? Yes, it's 4. So box that up, and now, say, all right, well, that's 4. So let's do my median. The median's pretty simple to figure out, too. It's not too tough. You're going to find the middle number. But whenever you deal with an even set of values, remember, how many did we have in this set?
8.
So whenever you deal with an even number or an even set of values, you know that you're never going to find a number exactly in the middle. I'm going to draw a line in the middle of this because I've got 4 numbers on the left right here. Got 4 numbers right here on the left and 4 numbers on the right. So right down the middle would be where my middle number should be. Well, I can't pull anything from the middle. So what you got to do in these situations with value sets of even numbers, you've got to take the mean of the 2 flanking or the 2 middles that are collected in the middle. So what's the mean of 3 and 8? Well, you take 3 plus 5, which is 8. I said 3 and 8. 3 plus 5. So 3 plus 5 over 2. Because I'm adding 2 numbers together, 3 plus 5. So 8 over 2 is 4. So now you find, hey, cool, the median and the mean are the same right here. The median and the mean are the same. However, this is not always the case. In fact, sometimes, or actually sometimes, the majority of the time, you're going to find out the mean and the median are different numbers. So you always want to make sure that you calculate them out. Always calculate them. All right, so the mode here. Well, the mode is the number that occurs most in the list. Well, let's look at what numbers occur most, or numbers. It's not just one number. It can be a number, or it can be multiple numbers. Well, what do you see up here, Bailey? Cameron, what do you see up here? Perfect. Cameron and P, that was for you too, by the way. So I should have been more detailed, but I thought when I heard the answer, that does not sound like Cameron P. Or maybe she's ill. Okay, so Cameron P, you're going to help me find the range. The range is the greatest number subtracted by the smallest number, the difference of the greatest and least greatest number. Yeah, so it's 8 minus 0 is 8. So 8 minus 0 equals 8. So now you can start to see that, hey, I've got values of 4, 4, 5, 8, and 8. So since you have values here, or numbers here, you can see that, hey, the mean, median, mode, and range can also be considered values. Sure, they're values because the range equals 8. So these are both considered values. All right, let's move on to something else real quick. We were talking about mode a second ago. But what happens when, say, I give you a set of numbers, a data set that looks like this? 13, 14, 15. Guys, what's my mode here? What does it mean? Huh? Why not? Wait, I'm hearing two different answers. Alex, I heard from you there is no number occurs most in this list is what you're telling me. Okay, Alex is saying nothing occurs more than the other here. But then, Avad, I heard you say something. You said they only occur one time?
They're all the same.
They only occur once. Okay. Well, that's kind of the same thing. Neither is greater than the other, and they all only occur once. So when they only occur once, and no value is there, they all occur once, so therefore there is not a number that occurs more than the other, like Alex said, hey, there's no mode. However, guys, what if I gave you this? I know, exciting, right? Who would like to take a stab at this one? Taylor? I know I'm picking on you here because you're writing. You want to take a guess at this one? Huh? What's that? So Taylor's saying, hey, it's all three of them. Anybody else have a stab at this too? I saw a lot of hands, so I'm just curious. What were you thinking, Dominique? What about you, Sam? So possibly there's none. Because before, why were you thinking that there were three modes, Taylor? They all occur more than once. However, Dominique and Sam, why did you think there were no modes? No number occurs more than the other. Here's the trick with this one. It's the rub down. It's the rub right here, guys. This is the fact. So what it is when they occur more than one time, if the numbers occur more than once, then you can have a mode, just like Taylor said. But since they all occur the same amount of times, 13 is twice, 14 occurs twice, 15 occurs twice, you have how many modes? 13, 14, and 15. Special case. Now, here's the deal. Since it occurs, we have three different modes. I call this trimodal. tri for 3, and modal for mode. Trimodal. Cool. Well, what if I were to do this? What if I said, I bet you guys can just guess this one. What if I said 13, 13, 14, no, 14. What would be my mode here? 13 and 14. Since I have two modes, what do I call this? Who said that? Bailey. Yeah, Bailey said, hey, if you have three modes and you call it trimodal, let's call this one bimodal if I have two modes. Because 13 occurs once or twice and 14 occurs twice. So it's bimodal. Bi for two, modal for mode. Two modes. Tri modes. Three modes. Trimodal. That should be like a commercial tone. Trimodal. I don't know. Yeah, doesn't it? That should be their new slogan. Let's go on, and we're going to look at one more thing here. Guys, sometimes you're given information. Here, I'll just give you a great example here. Sometimes you're given information, but there's too much of it. Here's a good example. Not too much. Did I tell you there's too much information? No, that's not the case. Sometimes a piece of information is lacking. I'll explain that in a second. Oh, I don't know. Trying to think of something, a good contest we could all have. What would be a good contest all this?
Fight to the death.
I think that one won't work here. But, no? Hot dog eating. Who's got another one? I like that one.
Okay, I got my gosh. Yes. I took 7 up. Yeah.
Huh?
I
I got it. An ice cream juggling contest. I know. So here's the deal. Not only somehow we've learned to freeze ice cream to where we can juggle it, and it just doesn't. I don't know. But here we go. We're going to juggle ice cream. We got this contest, but little do we know that little Miss Kathleen is an ice cream juggling world champion. She practices, trains year round. Does it? She hasn't told us. We don't know this, but she does. And she's a world-renowned champion. However, we don't know that. But we all have this contest, and what happens? They start the timer. We all start going. Well, hold your thoughts. And we do. We really do. Because you know what? All of us as a class, not including Kathleen, all of us as a class, all we can do is juggle, maybe three scoops of ice cream at most. Maybe even two. But on average, we're about 3. Okay, our average, what would our average, our mean be if we could all juggle 3? 3 scoops of ice cream. Our mean would be 3. However, Kathleen is trained so well, she can juggle 90 scoops of ice cream at one time. I know. It's incredible. I have seen it maybe once in my entire life, no more.
You've seen ice cream getting juggled before?
What do you think?
No.
I saw Kathleen. I saw her do this on the World Championships last year. It was just on TV last year. ESPN Sports. Wild and Crazy Sports. That's one of extreme sports. I think it's going to be in the next X Games next year. But here's what. So she can do 90. So hey guys, her value compared to us, just because she trains, it's we call it an outlier. It's just extreme. We call it an outlier. Hey, Kathleen, you have got this value that's an outlier compared to all of our values. So when that happens, guess what happens to the mean in that case? The mean is changing. It will change the mean. So what we do here, or what you want to do is say, well, does her 100 ice creams changing the mean up to, let's say it changed the mean to 10 rather than 3, does it really represent our average? No, because it's skewed our average. So within the special case and an outlier, you typically pull the outlier out of the data and just run the average of the majority. But let's look at some other information. Good job, by the way, on championships last year. You did great. Our next contest we'll talk about unicorn racing. So anyway, back on track. Pretty cool, huh? All right, so here we go. So here we go. We got 9. Let's say we got the values of 9, 6, 91, 5, 7. Oh, I don't know. Let's do a 6, an 8, an 8, a 7, and a 9. So these are all our values. Hey guys, you've got a list of unorganized information. What's the first thing that you want to do? Parse it and put it in order. So now I'm going to do this. I'm going to say, okay, well, my smallest value is 5. I'm done with it. Let's go to 6, 6, 7, 7, 8, 8, 9, 9. Now let's just do 91. Okay. So, Sam, the first goal here is to find the outlier. So you're going to look over at Dalton and say, Dalton, what do you think the outlier is, dude?
What do you think the outlier is, Dalton?
Well, I was going to say, hey, young blood, the outlier is 91. I don't know. I'm just making up words. So he's going to say, hey, buddy, it's 91, right? He's just going to say 91. So since it's 91, Sam, since it's 91, let's just pay attention to that for later on. We're just going to make a note of it right here. I'm just going to underline it as a note. Hey, this is my outlier. But guys, right now, I have 10 values in my data set. 10 values. And what I'm going to do here is show you guys how to solve the mean, median, and mode with and without the outlier. And let's just see if we see any differences. You all right, Dean? No. Okay, so this is going to be with the outlier. And that W with the slash means with. It's just a shorthand way. So what do you guys think that this W with the slash and an O means? Without the outlier. You are a genius. So now I have mean, median. I'm just going to spell median, M-E-D for now, and mode. Now, let's go ahead and start solving these problems. Well, the mean is all of this added together, including 91 right here. Well, the mean would be, this equals about 156 divided by 10. 156 divided by 10, well, that's going to be 15.6. So my mean is, with the outlier, 156 over 10, which equals 15.6. Let's go find the median. Well, I've got an even number here. So if I have an even number, what does that tell me about this data here? What's that? Say it again, Yvonne. Yeah, I'm going to have 2 numbers in the middle. So let's find out where those are. Well, I can kind of see it here. This is my first half, and this is my second half over here. So right down the middle, I'm going to be dealing with 7 and 8. And if you needed to count, you could say 2, 4, and 2, or 2 and 4. So now, okay, 7 and 8 are my middle numbers. So 7, what's the mean of 7 plus 8? Yeah, so I have 15 over 2, which equals 7.5. And automatically, guys, if you look up here, you see a difference, pretty large difference between the mean here and the median. the mean's almost double the median. In fact, it's more than double. I said almost. It's more than double. And the mode's pretty simple. I've got 2 6s, 2 7s, 8s, and 9s. So 6, 7, 8, 9. In fact, if I took 91 out of this equation here and only found the modes again, I would have the same mode, same as to the left. So it's the same values. So now, let's look at what the mean would be without this outlier. We're going to take the outlier out. So now, what I'm going to do here, just say, okay, all of these values here added up without the outlier is 65. And what would it be over? 65 over what? Over 9, yeah, because I cut the mean out. I'm not using it anymore. So since I cut the mean out, I only have 9 values, not 10. And that's going to equal closer to, think about 7 point. Who wants to race me on this? You already solved it? Good man. He's saying he already calculated it. It's 7.2. Did you say that it repeats? Okay. So 7.2. So now let's say this, guys. Okay, so if it's 7.2 repeating, let's find out what the median is. So what would the median be with 9 values? Well, remember, guys, with an odd set of values, what I'm going to do here is say, hey, we're getting rid of this. I've got an odd set now. I have 9 values. So what I'm going to do is find a middle number. 1, 2, 3, 4. 1, 2, 3, 4. And now my middle number is 7, right in the middle. Okay. So now I know that my median is 7. Now, if you look, I'm going to scratch that out and just write it over here for now. So the median and mean, using like different colors, with the outlier are much more separated or different than my mean and median without the outlier. Guys, if you were wanting to truly represent the average and post it on ESPN Live, showing to millions of people, would you want to represent the average using the outlier or without the outlier? Now, I understand that you can say that, but can somebody please explain why would you want to use it without the outlier compared to with the outlier? I'm going to ask Alex. I saw her hand raised first. Outlier offsets, well, I can set it better myself. The outlier offsets the normal data, and you see it right here with the mean as being 15 compared to 7.2. Remember, when we were juggling 3 scoops of ice cream, without Kathleen, our mean, the average mean is 3. But when she is added to the equation, it bumps us up to greater than 10. Did any of us touch more than 4 scoops of ice cream? No, we didn't even come close to 10. Although she could do 90, we didn't come close to 10 scoops of ice cream. So if our mean with an outlier that bumps us up to 10 compared to a mean that bumps us up to 3, what one truly represents us without Kathleen? 3. Absolutely. Absolutely. All right, guys. I think that's a great job. You guys can pull out your homework and begin. And Alex. What's up, dude? Alex, heads up. Sorry, man. What are you supposed to do? What? Why? What's it say? Yeah, you can make it up. You can use the textbooks from this class, or they just make up 5 or 10 different dress codes. Yeah. Why not, man? That guy really. I don't mind. You did it. Hey, you did it. I'm impressed. I said I was impressed. Get it all? Just so you can see. Again, I didn't know if you were guessing, but I was impressed. Hey. Yes, I love that really. Oh, Lewis, and it is a wonderful world, isn't it? Guys, thank you. Have a good one. Lewis, do you like that song?
Yeah.
What was your thought? Hey, Nazim. Haha, just kidding, I'm on. Maybe next week, buddy. Cameron. Cameron. Hey, picking other people's stuff up. That's rude. You could ask him. Say, hey, buddy, can I see that? Don't pick stuff up off their desk, crazy guy.